All right, these next couple problems are from section 9.2, so that's when we were solving quadratics by factoring. So these problems are going to go over just a couple different factoring methods. The first one, we have x squared plus 2x minus 3 equals 0. So if you remember for factoring, you want to draw yourself an x. We want to find two numbers that multiply to negative 3, but add to a positive 2. So go ahead and think for yourself. I'm thinking the number, let's see, a 3 and a negative 1. That's going to give us a negative 3 when we multiply them and a positive 2 when we add them. So because we have an a value of 1, that means the number in front of this x squared here is a 1, so that's why it's not even written. Because we have an a value of 1, we can go straight to our parentheses. So we have x plus 3 times x minus 1 is still equal to 0. So we have taken this side of our equation and we have rewritten it into two separate sets of parentheses. So then we're going to use the zero product property and we're going to say, hey, if these two things multiply together and they equal 0, that means one of them must be 0. So we're going to separate them into two separate equations and solve both of them for x. So we get the answer x equals negative 3 and x equals 1 for problem number 3. Problem number 4, very similar. The only difference here is we do have an a value here. So our a value is 3. Some of you are going to remember when you have an a value, when you go to draw your factoring x off to the side, you need to multiply 3 times 20 to get 60. That is the number we're trying to multiply to, and we're trying to add to negative 19. So we want to think of two numbers that multiply to give us a 60 and that add to give us a negative 19. So for us, that's going to be a negative 15 and a negative 4. A negative times a negative is going to give us a positive, but they're going to add together to give us a negative 19. Okay, now remember the difference here was that there is an a value. There's a 3 out front. So we cannot go straight to parentheses. We need to instead rewrite the negative 19x as a negative 15x and a negative 4x. So once we rewrite the negative 15 and the 4x, we will then factor by grouping. So I'm going to look at these first two terms here. What is the greatest common factor of 3x squared and negative 15x? 3x, right? That's what they both have in common. What's left if I factor out a 3x? Just an x minus a 5. Now I'm going to look at my next two terms here. So I have a negative 4x plus 20. Remember that the goal here when we're factoring by grouping is to get the same thing in the parentheses. So we're trying to get another x minus 5. So I know 4 is the GCF here, but if I only factor out a positive 4, then my signs are going to be wrong in my set of parentheses. So I'm actually going to factor out a negative 4. That means I'm going to have an x minus 5 left in my parentheses, which is perfect because that's exactly what I was going for, right? Now, both sets of parentheses are exactly the same term. So I can say that is the GCF. The GCF is x minus 5, that thing underlined in green. And what's left once I factor out the GCF is 3x minus 4. So those are the harder steps for problem 4 that aren't a part of problem 3. We are now at the point where we can use the zero product property. So we can say, hey, if those two things multiply together and equal 0, that means either x minus 5 is 0, or that means 3x minus 4 is 0. So we're going to solve both of those small equations. So we get x equals 5. In solving this one, I'm going to add 4 to both sides, so 3x equals 4. To get the x by itself, I'm going to divide by 3. X equals 4/3. So you can get a fraction. That is very possible. So for For problem number 4, you get that x is equal to 5 and x is equal to 4/3. So those are our two more simple methods of factoring. Number 3 being the simplest form, and then number 4 being when we have an a value. As you see, 5 and 6, they are not set equal to 0. So in the next video, I'll show you what to do to make it equal 0.